Hello kiddos, how are you? Welcome to PW Gulf. This is the recap session of the chapter ITF Inverse Trigonometric Functions. Before I start the session, let's do a small quick activity. I just got to know from some Instagram, so I thought let's do it in my classroom. It's supposed to increase the concentration, and I feel yes, it does work, because whenever I tried doing it, I found myself concentrating more. So we will all do it 5 times. What you are supposed to do? Interchange, right? This action, let's assume this is a rabbit and then this is pointing towards a rabbit. Change. Rabbit pointing towards the rabbit. Rabbit pointing towards, rabbit pointing towards, rabbit pointing towards, rabbit pointing towards, rabbit pointing towards. So you do this 5 times before you start the session. If you are able to do it, great. And let's proceed with what is ITF. ITF chapter. What all things this chapter includes from the board perspective? A lot of things are removed, but yes, here we focus a lot on the competitive examination. So I am teaching everything from the scratch. Whatever is there in the textbook, the deleted portion is also covered here in the lectures. Introduction, composition of ITF, results in ITF, some properties of ITFs. These two combined is nothing but properties of ITF, and then final thing, simplification of ITF. These are all the things we will be covering in today's class. I know that this chapter will need lot of question practice. There is a set of formulas which you have to remember and then apply it in the questions. What I am doing, formulas definitely I'll go through. I'll also give some tricks to remember it. Next thing, we will solve lot of questions. The first and foremost thing when it comes to ITF chapter, all I ask my students is do nothing but just remember by heart this table. How is this table? Where is this table appearing from suddenly? There is no magic behind it. You have all studied in your class 11th about trigonometric functions, their domain and their range, isn't it? Have you all studied? Of course, ma'am. Sin x, what was its domain? All real numbers, range was -1 to 1. Similarly, cos x, domain was all real numbers, range was -1 to 1. And for all other functions, tan x, domain was all real numbers except the odd multiples of 90, because tan 90 is not defined. So odd multiples of 90 should be subtracted. Range was all real numbers. Cot x, range was all real numbers, but the domain was all real numbers except even multiples of 90, that's 2n pi, or I should say just n pi. Sec x, all real numbers. Where is what is the domain of sec x? Where is sec x not defined? Sec of 90 is not defined, so all real numbers except odd multiples of 90. And domain was all real numbers except -1 to 1. You must have also seen it like this, minus infinity to -1 union 1 to infinity. Am I correct? And last one, cosec x. Cosec of 0 is not defined, so from all real numbers you remove the even multiples of 90, which is n pi, and range will be same as your sec x. Alright, so this was your trigonometric functions, domain and range. Now instead of sine, cos, tan, sec, cosec, cot, I want their inverse. That means domain will become range, range will become domain. Domain should become range, range should become domain. So yes, you can see this domain is nothing but range copied as it is. Fine, cool, great. But the range is not same as domain. Do you see the range to be same as domain? Sorry, yes. Here the domain is all real numbers for sine and cos, whereas here the domain is -90 to +90. This is 0 to not p, pi actually. I'll write it with red color pen. 0 to pi, 0 to pi. Yeah, correct. So why is this range not equal to the domain? This range is not equal to the domain Because these are principal value branches. What is principal value branches? In short, called as PVB. The whole concept of PVB is to make it bijective functions. To make your sine, cos, tan a bijective function, this particular PVB is selected. How? Why? Let's discuss in short. I'll be doing it for one function. Assume it for all other functions. Let's say your sine x. Let's talk about sine x function. What will be the inputs of sine x? 0, some positive numbers, some negative numbers. So 0, minus 30, minus 60, plus 60, and then plus 90, minus 90. These are some of the inputs. What is the, when input is 0, output is 0. Right? Okay. Okay. Chuck it. So let's take a function sine x. Y is equal to sine x. Some values of sine x like 0, minus pi, plus pi, minus 2 pi, plus 2 pi. What is sine 0? 0. What is sine pi? 0. What is sine 2 pi? 0. What is... All these values are giving me the answer as zeros. It is many to one function, and do you remember for inverse there is one condition, a function should be bijective. Do you remember this? The function should be bijective. That means both 1 to 1 and 1 to. Right now it's many to one. That means sine function, its inverse will not exist. But for the inverse to exist, we are making a slight change. What is that small change which we are making in the sine function? Let's say we are taking some positive values, negative values. Positive values first I'll take pi by, always I take pi by 3, pi by 6, pi by 3 and pi by 2. And negative values similarly minus pi by 6, minus pi by 3 and minus pi by 2. I have taken plus 90 to minus 90, the inputs. I have restricted the domain. I have restricted the domain from plus 90 to minus 90. What will be the output? Sine 0 is 0. Sine 60 is 1 by 2. Minus 60 is minus 1 by 2. Not 60, 30. Minus, minus root 3 by 2. And here again 60 is plus root 3 by 2. Sine 90 is 1. Sine minus 90 is minus 1. Can you see this function is bijective now? This is very much a bijective function. This is very much a bijective function, that is, it is 1 to 1 as well as on to. How did we get from a non-bijective function to a bijective function? This was non-bijective. How did I convert this non-bijective function to a bijective function? By restricting the domain to minus 90 to plus 90. By restricting the domain of sine x to minus 90 and plus 90. So it is the domain of sine x. For sine inverse x, it will become the range. Do you agree? So for sine inverse x, this is the range, minus 90 to plus 90. Similarly, for cos inverse x, instead of having all the numbers, we restrict it to 0 to pi. And then for cosec, sec, cot, tan, everything. Right. The best way to remember this chart, is, I'll tell you on the next slide. Just remember there are two families. Now with the help of these two families, we will be solving most of the questions. 0, pi by 2, this is pi, and this value, let's say it's minus pi by 2, because if you go clockwise, it's taken negative, anti-clockwise positive, clockwise negative. Right. If you observe that table very well, there are two families, family 1, fam 1, fam 2. Let's call them fam 1, fam 2. Family 1 has seta cosec. What is theta cosec? Sine, tan and cosec. Theta cosec. Family 2 has cosec cot, 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 cosec cot. What is cosec cot? Cos, sec and cot. Cos, sec and cot. Cosec cot, cos, sec, cot. Okay, these two families, what is the difference? The first family is always minus 90 to plus 90. The second family is 0 to pi. First family is always minus 90 to plus 90. Second family is 0 to pi. Now minus 90 to plus 90, sometimes closed interval, sometimes open interval, sometimes we remove 0 from it. Here also sometimes closed, sometimes open, sometimes we remove 90 out of it. For example, refer this table. Theta cosec. Just look at the families. Can you see sine inverse minus 90 to plus 90? Tan inverse minus 90 to plus 90, open interval, and cosec minus 90 to plus 90 except 0. So theta cosec, one family. Theta cosec, one family. The other family, cos, sec, cot. Can you see cos 0 to pi family? Closed interval. Sec 0 to pi except 90. Why 90 is removed? Because sec 90 not defined. Similarly, y 0 is removed, cos sec of 0 is not defined. And cot 0 to pi, why open interval? This is an open interval. Reason simple, cos cot of 0, cot of pi, both is not defined, right? Cot 0, cot pi, we say it's not defined. Similarly, at tan you see open interval. Why? Because tan 90 is not defined. So at 90 there is open interval. Sine and cos both have closed intervals. Cosec and sec have closed intervals, but you remove certain terms, and tan and cot both have open intervals. Can you see the blue family? Second family, fam 2, cosec cot, cosec cot, cosec cot, 0 to pi, 0 to pi, 0 to pi. Fam 2 is 0 to pi, 0 to pi, 0 to pi. Fam 1 is theta cosec, theta cosec, theta cosec, minus 90 to plus 90. Minus 90 to plus 90. Just change the intervals. Closed, closed except 0, open. Right? So that's the way. There are two fams to divide the inverse trigonometric functions. The first family, theta cosec, is minus 90 to plus 90. The first family is in minus 90 to plus 90. That means the first family will lie in this range. Theta cosec, first family, minus 90 to plus 90. Whereas the second family was 0 to pi. 0, pi. The second family, which was cos, sec, cot. Nothing in the third quadrant. In third quadrant, nothing goes. Everything in first, second, or first and fourth. Nothing in third quadrant. So will you now remember, for sine, closed interval, for tan, open interval, for cosec, closed interval except 0, because cosec 0 not defined. For second family, cos, closed interval, sec, closed interval, minus 90, remove 90, sec 90 not defined. For cot, open interval. Alright. Next, let's go to the questions, properties, what say guys. So there are, after you by heart the table, the first and foremost request from all of you is by heart that first table thoroughly. That is the domain and principal value branch of theta cosec and cosec cot. Next thing is some basic properties. What basic properties? Two basic properties I'll be talking about. The two basic properties are, first one, T inverse of T theta will be equal to theta, and the second is T of T inverse theta is equal to theta. Couldn't understand? Alright, I'll take an example. The first thing, for example, you have sine inverse of sine theta. Sine inverse sine will cancel up to give you theta, provided theta belongs to the domain of sine. What is the domain of sine? The domain of sine, or it belongs to the range of sine inverse, whatever. Domain of sine is all minus 90 to plus 90. Do you remember? Theta cosec. Domain of sine or range of sine inverse. Just now we saw range of sine inverse is minus 90 to plus 90. Similarly, cos inverse of cos theta is equal to theta. Now what should this theta be? It is the answer of cos inverse. It is the answer of cos inverse. That is, answer means range. Range of cos inverse, it should be 0 to pi. And similarly for all other trigonometric functions, can you write in a similar way? Tan inverse of tan theta will give you theta only when theta belongs to first family, right? Tan is first family, so minus 90 to plus 90. And then rest of the three. Let's go to the second part. Sine of sine inverse theta. This will give me answer as theta. Sine inverse cancels, answer is theta. Provided this theta belongs to what? It belongs to domain of sine inverse. What was the domain of sine inverse? Minus 1 to plus 1. Cos of cos inverse theta. This is equal to theta, provided theta belongs to minus 1 to plus 1. For sine cos, it's same. Tan of tan inverse theta is same as theta, provided your theta belongs to what? All real numbers? Think. What was the domain of tan inverse? Getting a little confused? Alright. What was the range? We talked about the range here. Minus 90 to plus 90. Instead of all real numbers except odd multiples, we have just taken minus 90 to plus 90. Here it is all real numbers, minus infinity to plus infinity. Check. Can you see? Right. Good. So you should be able to reason out each and everything. Now once you have understood the two basic properties, basic property 1 and 2, I just wrote basic property 1 and 2 here. After these two properties are understood, we'll move on to the 6 properties given in the textbook. All the questions will be solved based on these 6 properties. The first property, sine inverse of 1 by x is cosec inverse of x, cos inverse of 1 by x and tan inverse of 1 by x are nothing but the reciprocal. So let's call this property as property of reciprocals. What say guys? 1 by x will become x. This thing, whatever x is written, it is from the, it is nothing but the domain of cosec and sec. X is greater than equal to 1, less than equal to minus 1. What is that? Domain of sec. These two actually means all real numbers except minus 1 to 1, or minus infinity to minus 1 union 1 to infinity. That same way of writing this. For sec cosec and for cot, you know it should be greater than 0. Alright. What if it's less than 0? Something missing? Let me add a formula. So a lot of things are missing in the textbook, which is not wrong, but yeah, for board level it is not needed. For entrance level it is needed, and I will be including that. Nothing to worry. Alright. Tan inverse of 1 by x is minus pi plus cot inverse of x when x is less than 0. That's the fourth one which you can add. The first property, reciprocal property, you will be able to remember. Second property is sine inverse of minus x equal to minus sine inverse of x. Tan of, so in theta cosec, that's your fam 1. Let's say fam 1, theta cosec. Whenever there is a negative sign in fam 1, negative sign comes out. Aha, so nice. So suppose you have sine inverse of minus root 3 by 2. Minus sign will come out and sine inverse of root 3 by 2 will be left, which is minus. Sine inverse of root 3 by 2. When is the value of sine as root 3 by 2? At 60 degree, which is pi by 3. Right. So using FAM1, this property, lot of questions of this sort can be easily solved. Cosec cot. FAM2, cosec cot. Whenever there is a minus sign in FAM2, the minus doesn't comes out easily. There's a pi. They call a pi. They call a pi. So minus sign in second family, pi will be called up. Right. Okay. So for example, you have cos inverse of minus 1 by 2. You will not write it as minus cos inverse of 1 by 2. No. There is calling of pi. Pi minus cos inverse of 1 by 2. This becomes positive, which is pi minus, when is cos value equal to half? Again at 60 degree, which is pi by 3. 2 pi by 3 happens to be the answer for this. Right? Similarly for sec and cot. That's your property 3. 3 properties done. First property was reciprocal. Second was your FAM1. Third was FAM2. Fourth property is complementary. This property is your complementary property. Now what do you mean by complementary property? Sine and cos are complementaries of each other. Tan and cot, sec and cosec are complementary. So when you add the complementaries, the answer should be 90 pi by 2. That's it. Fourth property done. Fifth property, tan inverse of x plus tan inverse of y minus and this. So all this fifth property is nothing but tan exclusive property, isn't it? Everything related to tan. There is nothing else, just tan on the LHS, on the RHS, everything tan, 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 tan property. Remember plus sign, we have x plus y upon 1 minus xy. When there is a minus sign, we will have numerator negative and denominator should be positive. Always opposite sign. Plus means numerator plus, denominator its opposite sign. If there is a minus, numerator is minus, denominator will have its opposite sign, that's plus. 2 times tan inverse of x is tan inverse of 2x upon 1 minus x square. You are also aware of this thing, isn't it? Right. Please remember, this is applicable only when xy is less than minus 1. Not otherwise. So always check whether your xy is less than minus 1 or not, and only then you apply this property. Alright. Next one. That's tan exclusive property. The sixth property is LHS is tan, but RHS is sine, cos, tan, everything. So it's not tan exclusive, but tan to other functions. Tan to other functions. So whenever you have tan and you want to be converted in terms of sine, 2 times tan inverse x is sine inverse of 2x upon 1 minus x square. 2 times tan inverse of this is cos inverse of 1 minus x square upon 1 plus x square. And 2 times tan inverse of x, we just wrote it is equal to 2x upon 1 plus x square, where these two properties are contradicting. So let's quickly find the right one. If this is your plus, denominators cancel, this should be minus. I have corrected the typings. Sine inverse of 2x upon 1 plus x square, cos inverse of 1 minus x square upon 1 plus x square. When you divide sine and cos, you should get tan. So when you divide sine and cos, denominators cancel and remaining thing is 2x upon 1 minus x square. So you should also keep this in mind whenever you are getting stuck. Remember your 11th standard trigonometric formulas, that also help. What was the formula of tan 2 theta? 2 tan theta upon 1 minus tan square theta. So just instead of tan, you have x now. Right. This is your sixth property wherein you are converting tan to some other function. Some extra formulas which might be needed. Example, sine inverse of x plus sine inverse of y. Let's say you have something of this sort. It can be written as sine inverse of x root 1 minus y square plus y root 1 minus x square. Right? Similarly, if there is a negative sign, sine inverse of x minus sine inverse of y, you will write the same formula but with a negative sign in between, nothing else. And for cos inverse x plus cos inverse y, it is cos inverse of, now you know c for cos, c for change, s for sin, s for same. So in sin the formula, the sign is same, plus plus minus minus, but in cos, if there's a plus here, it will change to minus, right? And the formula also changes a bit. It's xy minus root of 1 minus x square into root of 1 minus y square. And for cos inverse of x minus cos inverse of y, it will be cos inverse of xy. Here minus, so I'm going to put plus. So couple of this extra formulas, just whenever you encounter a question, let's say sin inverse of 3 by 5 plus sin inverse of 1 by 2. So use this and you will get the final answer very easily. Well, I will be using another method to solve the question. There are various approaches to solve the question. Let's say here is a very simple question. Prove that sin inverse of minus root 3 is minus pi by 3. Using the fam1 property, minus sign comes out and you get the answer. So using properties, it's very easy, isn't it? Let me do it using properties and then the actual method without using properties, which is a little lengthy, but all right. Okay, so if I take the LHS, sin inverse of minus root 3 by 2. Now what is the property? Fam1 property. Property 2 is fam1. Minus sign comes out of the inverse and we will be left with root 3 by 2, which is equal to, minus sign is there already, sin inverse of root 3 by 2. When is sin equal to root 3 by 2? At 60 degree. And that's your RHS, hence proved. That's one way. Alright, simple. Another way which you must have been taught in the school is, let sin inverse of minus root 3 by 2 be equal to x or y, anything. Okay, next. Taking sign on the other side, sin y is equal to minus root 3 by 2. Sin y is equal to, we need to find the value of y now. Question is, we will find the y. Sin y is equal to minus, when is sin equal to root 3 by 2? It is equal to root 3 by 2 at 60 degree. So minus sign outside, root 3 by 2 is sin pi by 3. Can I cancel the sign from both sides? Not yet. Not yet. In order to cancel, you have to take care of the minus sign. This minus sign will go inside. Reason? What is the reason? Sin of minus theta is same as minus sin theta. Sin of minus theta is same as minus sin theta. So if outside minus sign, it can go inside. Now the sign will cancel up in a way and the answer is minus pi by 3. There is a reason. Minus pi by 3 belongs to the principal value branch of sin. Minus pi by 3 belongs to the principal value of sin inverse. And what is y? Y is nothing but RHS, right? Therefore, sin inverse of minus root 3 by 2 is equal to minus pi by 3. Hence proof. Both the approaches, shorter, longer. So if you have properties in your school, if the properties have been deleted for you, only thing, whenever you are cancelling sign, do not show that you are cancelling sign, first thing. Second, you have to understand sign have been nullified from both the sides, and when you nullify, ensure this value minus pi by 3, it belongs to the PVB. Like you cannot randomly cancel any two numbers. Example, you have sine of 2 pi by 3 on the left side and sine of y on the right side. Can you remove this sign and say y is 2 pi by 3? No. Why? 2 pi by 3, which is 120 degree, doesn't belong to minus 90 to plus 90. Is 120 degree belonging to the PVB? It doesn't belong. So you cannot remove the sign and say the answer is 120. So in order to remove the sign, you have to ensure that this belongs to PVB. Okay. So what to do in question like this, when you appear question sine of 2 pi by 3 is equal to sine y, and this is not a part of PVB, what to do in such a question? What to do in such a question? Don't worry, I am here to help you out. Before that, another question. So right now, since I have taught you the property, I will do the questions with the help of properties. It's very easy, and yes, we have more scope when we include properties. When we don't include properties, the scope of chapter is minimized to only few questions. Only exercise 1, which is hardly anything, you must have seen in your NCERT. But when you include properties, the scope expands. Next question, can I just cancel cos inverse and cos and say answer is 5 by 3? No, it's not matching with the RHS. Why can't I cancel cos inverse and cos? Why can't I do that? Like here, why cannot I cancel? Because in order to use this property, cos inverse of cos theta is equal to theta, you have to ensure that theta belongs to the PVB of cos inverse, which is 0 to pi. This value should belong to 0 to 180. Right now it's 300. 300 is not within the PVB. What to do? Come here. LHS. Cos inverse of cos 5 pi by 3. Alright. Cos inverse of cos 5 pi by 3. Can I write it as 2 pi minus pi by 3? So in order to bring it in 0 to pi, I am doing all this. So just check. I have written it as 2 pi minus pi by 3. I cannot write it as pi minus pi by 3. That is not giving me 5 pi by 3. So yeah, right now it's like this. Cos inverse of cos. What is cos of 2 pi minus theta? Isn't it cos theta? Fourth quadrant, and fourth quadrant cos is positive. So cos of 2 pi minus pi by 3 is cos pi by 3. Can I remove the cos now? Whenever it's LHS, equal to can be taken. Cos inverse cancel, it's equal to pi by 3. That's RHS. Why cos inverse cancel? Because pi by 3 belongs to the PVB. So please write down the reason. This inverted 3 dots means since. This is nothing but your since pi by 3 belongs to the PVB 0 to pi. Pi by 3 belongs to 0 to pi. That's why cos inverse cos got nullified, and the answer is pi by 3, which is RHS, hence proved. Question is over. Done, sorted. Some basic questions I am taking just for the understanding purpose, for getting the grip. After this, I will be taking few more theoretical part and then questions. Couple of more basic questions. Let's say you have sine inverse of sine of 600 degree. Okay, find out or solve the value of sine inverse of sine 600 degree. Can I just cancel sine inverse sine and say answer is 600 degree? No, because sine inverse of sine theta will be equal to theta if theta belongs to minus 90 to plus 90. 600 is out of this range, so I cannot cancel. Then try to bring this within the PVB, within minus 90 to plus 90. And how to do that? 600 can be written as 720 minus 60. No. 600 is not 720 minus 60, is it? No. 600 can be written as 630 minus 30. Shall I write? But I don't want to change sine to cos. So I will write it as 540 plus 60. Where is 540? 0, 90, 180, 270, 360, 450, 540. So 540 is over here. And 540 plus 60, which means it will be in third quadrant. What happens to sine in third quadrant? Sine of 540 plus theta minus sine theta. In third quadrant, sine is negative. So sine of 540 plus theta is minus sine theta. Sine inverse of minus theta, what happens? What happens to minus sine theta? Which is sine inverse of minus sine 60 root 3 by 2. Sine inverse of minus root 3 by 2 using the property. It is minus comes out and sine inverse of root 3 by 2 is minus pi by 3. What is the property we have used? P2. Sine inverse of minus theta is minus sine inverse of theta. So minus out, sine inverse of root 3 by 2 is pi by 3. Question solved. Sine inverse of sine 600 is nothing but minus pi by 3. Can you all understand this question? Understand the reason. You can pause, understand why at all ma'am did 540 plus 60. Why ma'am didn't choose 630 minus 30. 630 minus 30 is also 600. But 630 would have been here on the y-axis. And if I take sine of 630 minus 30, what is sine of 630 minus theta? It is cos theta and with a negative sign. Minus cos theta. Do I want to change this sign to cos? Am I stupid? No. Outside there is sine inverse, so inside also we want to maintain sine. We don't want to change this sign to cos. So sine of 630 minus theta would have changed it to cos. Don't do that. Keep the sign. 540 plus 60 makes a lot of sense. And sine of 540 plus theta minus sine theta. Sine 60 root 3 by 2 minus comes out by the property P2 and we get the answer. Understood? Okay. Fine. Do you want some more basic questions? Just check. Let's say if you have sine inverse of sine inverse of root 3 by 2. When is sine equal to root 3 by 2? At 60 degree, pi by 3. If you have sine inverse of minus root 3 by 2, minus pi by 3. In the first family, what happens? Minus sign just comes out. Tan inverse of minus 1, or let's say first plus 1, it's pi by 4. Tan inverse of minus 1, it will be minus pi by 4. Because theta cosec first family, minus sign comes out. Instead, if you have second family, let's say root 3 by 2, what is it? Pi by 6. But cos inverse of minus root 3 by 2, if you have cos inverse of minus root 3 by 2, will minus sign just come out easily? No. You will have to do pi minus and then cos inverse, when is it root 3? Pi by 6. The answer will be 5 pi by 6. Okay. Next, let's say if you have cot inverse of minus 1. We know the value of cot is 1 at pi by 4. So, is the answer pi by 4? No. Is the answer minus pi by 4? No. You will call a pi. Pi minus pi by 4, that's 3 pi by 4. Alright. Similarly, if you have sec inverse of, let's say, root 2 minus root 2. When is the value of sec equal to root 2? 45. But because there is a minus sign, pi minus pi by 4. This is again 3 pi by 4. So, always fam 1, whenever there is a negative sign, you bring out the negative very easily. But in fam 2, negative sign means you will call upon a pi. You will be calling pi. Alright, are we able to understand? Fam 1, fam 2. In fam 1, whenever you have trigonometric of negative angle, the answer is simply minus. Minus is taken out. Alright. And if it is plus theta, the answer is as it is. But in family 2, if you have negative sign, what happens? Pi is called. If you have positive, it is as it is. So that's the difference which we learned by far. In the previous slide, that's what you learned. Family 1, family 2. Positive as it is, negative. For positive, as it is we write the answer, but for negative you change it. Pythagoras formula. We all know about the Pythagora, not Kala Kala. Very Gora. Very, very racist. Pythagoras theorem. What is this Pythagoras theorem? Simply one side square plus other side square is equal to hypotenuse square. How do we use it in our concept? Here we go. Suppose in this triangle, side opposite to theta is x. Hypotenuse is 1. So what will be adjacent side? Root of 1 minus x square. Do you get it? If sine of theta is x, opposite upon adjacent, cos of theta will be root 1 minus x square upon tan of theta will be opposite upon x upon root 1 minus x square. And similarly you can write from here, you can write cosec, that's 1 by x, sec, which is 1 upon root 1 minus x square, and cot, that's equal to root 1 minus x square upon x. Not a big deal. Just by this triangle you understand these values. How is supposed to be used in a question? So certain triplets are quite common, and let me write those triplets for you, will be used very often. 3, 4, 5. This is the most standard Pythagorean triplet, and we'll be exploring this further also. One more is your 12 square plus what? 5, 12 and 13, 5 square plus 12 square is equal to 13 square. Another one, 16, 63 and 65. 16 square plus 63 square is equal to 65. Last one is 8, 15 and 17. Just check, I'm not very sure. 64, 15 square, 20, 225 plus 64, 89, 289, 17 square. These 4 standard mostly will be using this 4 triplets in the question, and whenever you come across these numbers, know that the question is going to simplify very nicely. For the first case, now let's take this first triangle 3, 4, 5. All we are learning in this triangle method, I generally refer it as triangle method. Let's say this is your triangle given 3, 4, 5. We are learning how to convert interconversion, sine to cos, cos to tan, cot, tan, etc. If one of the trigonometric function is known to you, inverse trigonometric function, you should be able to convert it into any other trigonometric function. Example, in this question, what is, let's say sine inverse of 3 by 5 is equal to theta, or in other words, sine theta is 3 by 5. Do you agree? Sine is opposite upon hypotenuse, sine theta is 3 by 5. So theta is sine inverse of 3 by 5. Now I want to convert this theta not just in terms of sine but also in terms of cos, tan, cot, etc. everything. So this same theta I can write in terms of cos as cos is adjacent upon hypotenuse 4 by 5. Also in terms of tan, tan will be opposite upon adjacent. Cot will be reciprocal of that, and sec will be reciprocal of cos 5 by 4. Cosec will be reciprocal of sine, which is 5 by 3. Can you see just one angle is known to us, sine inverse. We can write it in terms of cos inverse, tan inverse, sec, cot, well, whatever is needed. Why is that done? Suppose you have a question like this. Sine inverse of cos, or let's say, yeah, sine of cos inverse 3 by 5. How can I cancel sine and cos inverse? Not possible. If outside there is sine, inside I need sine inverse. How do I convert this cos inverse into sine inverse? Very easy. How to convert cos inverse into sine inverse? Very easy. Cos is 3 by 5. That means adjacent 3, hypotenuse 5. Opposite will be automatically 4. Cos is adjacent upon hypotenuse. Adjacent 3, opposite hypotenuse 5. Opposite will be 4. In this triangle, I don't want cos, I want sine. So from this triangle, sine inverse of opposite upon adjacent. And now sine inverse will go off and we'll get the answer to be equal to 4 by 5. Very easy. Understood? So whenever you have different functions, we instead of cos we needed sine. We use the triangle. The triangle method is going to be very helpful to you guys. Please remember this interconversion. Now enough of theory. What say guys? Enough of theory. Let's jump on to the questions. Some few questions I have, 7, 8, 10. That's it. Sine of 2 sine inverse 3 by 5. And these questions are not your textual questions. It's a little step above. Let's say this theta is sine inverse of 3 by 5. Just now we saw interconversion formula. So this is based on the interconversion formula. Let's say theta is sine inverse of 3 by 5. Alright. We cannot cancel sine and sine inverse. There is a 2 present. Keep that in mind. Alright. So what is sine of 2 theta? It is 2 sine theta into cos theta. Agreed everyone? 2 sine theta into cos theta. What's theta? Theta is sine inverse 3 by 5. So 2 sine inverse 3 by 5 into cos sine inverse 3 by 5. Your sine inverse will go off. But what about cos and sine inverse? I cannot cancel that. Make this sine inverse as cos inverse. How? Draw a simple triangle very quickly. Can you see? 3 by 5, opposite is 3, hypotenuse is 5, adjacent will be 4. And now substitute 2 times sine of sine inverse 3 by 5 into cos of, instead of sine inverse, from the same triangle, write cos inverse, adjacent upon hypotenuse. Sine inverse, cos inverse gone. 2 into 3 by 5 into 4 by 5. 5 5s are 25, 2 3s are 6, 4s are 24. 24 upon 25 is the answer to this question. Very easy. Now in the next question, I am not even going to write this sine of sine inverse, cos of sine inverse. Immediately you should understand theta is in terms of sine. So sine and this theta sine will cancel. Cos of theta. So we will quickly make a triangle and resubstitute. Check, for example, sine of 2 sine inverse minus 4 by 5. According to the fam2 property, minus sign comes out. Alright. Sine of minus 2 sine inverse 4 by 5. The minus sign has come out. Right? Okay. There is also one more property. Here we used property 2, which is sine inverse of minus theta is equal to minus sine inverse of theta. Another property, sine of minus theta is minus sine theta. Do you agree? Sine of minus theta is minus sine theta. So this minus will again come out and we'll be left with 2 sine inverse of 4 by 5. And this is now very similar to the question you just did, isn't it? Sine 2 sine inverse 3 by 5. Here there is sine 2 sine inverse 4 by 5. Aha, you know this is going to be your theta. So let sine inverse of 4 by 5 be equal to theta. That means the question turns into minus sine of 2 theta. Simplifying it, minus as it is 2 sine theta into cos theta, which is minus 2. From the triangle, draw the triangle properly, Pythagoras theorem. Sine of 4 by 5. This time opposite is 4, adjacent is 3. Opposite 4, hypotenuse 5. That means adjacent will be 3. Pythagorean triplet. Opposite 4. Okay. Sine theta. From this triangle, what is sine theta? Opposite upon hypotenuse. And what is cos theta in this triangle? Adjacent upon hypotenuse. So directly from the triangle, we can get the value. 5 5s are 25 and numerator is 4. Same, 24. There is a minus sign. The only difference is a presence of minus sign, and this reasons should be noted. Triangle should be made to show. Getting it? Awesome, blossom. Next, when there is cos inverse of minus theta, what happens to the minus? We call a pi. So here also we are going to call a pi. Cos inverse of minus theta will be pi minus cos inverse of 3 by 5. Reason, cos inverse of minus theta is pi minus cos inverse of theta. Okay. Open up, simplify. Sine of 2 pi minus 2 times cos inverse of 3 by 5. What is sine of 2 pi minus theta? It's minus sine theta, right? In fourth quadrant, sine is negative. Sine of 2 pi minus theta is minus sine theta. That is equal to minus, let it be outside. You are going to now assume, let cos inverse of 3 by 5 be equal to your theta. That means the question has turned into minus sine of 2 theta. Minus as it is 2 sine theta into cos theta. Let's find the value of sine theta cos theta from the triangle. What is the triangle going to look like? Cos 3 by 5. Cos is adjacent upon hypotenuse. So adjacent 3, hypotenuse 5. Opposite will be automatically 4. From this triangle, what is sine value? Sine theta is 4 by 5. Cos theta is 3 by 5. And the answer is once again minus 24 by 25. The answer is all ranging in minus 24 by 25 plus 24 by 25. But look at the technique, how we are using the basics of trigonometry. This is like 11th standard trigonometry. If you don't know 11th, how are you here present to learn class 12 trigonometry? It's not possible. So in case you're struggling with your class 11 trigonometry, do not watch this video. Go and watch class 11 trigonometric video, which is already there, recorded by me. Try to learn those basics. This should be very quick. You shouldn't be struggling with these basics, right? This should be very, very, very quick. Only then you can solve such type of questions. So the answer is there. Sine of 3 times sine inverse 2 by 5. Let's call this sine inverse of 2 by 5 to be equal to theta. What say? Yes. Question becomes sine of 3 theta. And what is sine of 3 theta? By the formula 3 sine theta minus 4 sine cube theta. Once again class 11th formula. Triple angle, which is equal to 3 sine theta. Sine theta is 2 by 5 minus 4 into sine theta 2 by 5, and it's cubed also. Can you see from here? Sine theta is 2 by 5. Right. 6 by 5. 5 cube is 125. 2 cube is 8. 4 8s are 32. And yeah, let's take the common denominator, which is 125. 25 multiply divide, 25 6 are 25 6 are 150 minus 32, that's equal to 18 upon 125. Any plus minus sign to be taken care? No, it's all good, right? 150. The answer is 18 upon 25. Cool? Very good. Next question. Prove LHS is equal to RHS. Sine inverse of 3 by 5 minus sine inverse of 8 by 17 is equal to cos inverse of something. Now you remember I gave you some extra formulas. You can use those extra formulas. That's one method. I'll do by the other method. What is my other method? What is the other approach? Can you guys think of any other approach to solve this question? Yeah, so there is a very beautiful way. Just consider your LHS. Minus sine inverse of 8 by 17. In this entire thing, I am taking cos. Just taking cos. Remember, you are taking cos on your own. So in the end, you are supposed to adjust that cos. I have taken cos. What is cos of A minus B? Cos of A minus B is cos A cos B minus sin A sin B. Yes. It's cos A into cos B, cos A cos B minus sin A is sin inverse 3 by 5 into sin B, B is sin inverse 8 by 17. Now 8, 17, is it forming any Pythagorean triplet? 3, 5, is it forming a Pythagorean triplet? Yes, right. 3, 4, 5. Can you see sin 3 opposite hypotenuse, so adjacent will be by default. Another triangle, let's say this is your x, so opposite is 8, hypotenuse is 17. What should be this? 8 square 64, 17 square is 289, 15 square is 225 plus 64 gives us 17 square, right? So that's another triangle. Okay, now can you answer this without actually solving? Inside there is sin inverse, outside there is cos. I don't like this sin inverse, we don't like this sin inverse, we want the sin inverse to be cos inverse. And how do I convert? So look in the triangle, what is cos? What is cos? I can write it as cos inverse as adjacent upon hypotenuse. In this triangle, adjacent upon hypotenuse into cos. Once again, we don't like this sin inverse, we want cos inverse. So in that triangle, cos is adjacent upon hypotenuse, 15 by 17. Here, yes, we like sin 3 by 5 into sin cancel 8 by 17. And what is 17 5s are? Cos inverse 4 by 5 into 15 by 17 minus 3 by 5 into 8 by 17. Just get the answer. 85 is the denominator. 15 4s will be your 60 and 3 8s are 24. And how much is that? 36 upon 85. If there is any mistake here and there, please understand this is not a retake session, it's a one take session and mistakes are bound to happen a little bit here and there. If you sure about it, correct it. Some calculation mistakes. 60 minus 24, 36. It's correct. It's correct. Just check. We drew two triangles. Here sin inverse and sin inverse were additional. We wanted it in terms of cos. So instead of 3 by 5, we wrote 4 by 5. Instead of 8 by 17, we wrote 15 by 17 and converted it into cos. Similarly, okay, the question is not complete. What do we get this? This is your 36 by 85, right? This is your 36 by 85. Where is it? We have to prove it to be equal to 84 by 85. And how to do that? Because there should be plus. I was talking about calculation mistake. You should have told me, right? 60 plus 24 is 84 by 85. What is cos of A minus B? Cos A cos B plus sin A sin B. Cos of A minus B. C for cos, C for change. Minus sin changes to plus sin in cos. C for cos, C for change. So yeah, we have got 84 by 85 on solving the LHS. Can you check the RHS? LHS is including the cos, right? If you want to remove, so in the RHS also you include your cos. If you have included cos in LHS, put it in RHS also. What's the harm? So cos of cos inverse 84 by 85. Cos inverse goes 84 by 85. Can you now see LHS is equal to RHS? Hence proved. You all can see LHS is equal to RHS, hence proved. So in the LHS we added cos on our own. In the RHS also we put cos. And then check LHS is equal to RHS or not. Similarly, next question, something is to be proven to be equal to sin inverse of 77 by 85. Once again, LHS. Now, do you want to take sin or cos? Let's take sin this time. We are including sin on our own this time. Everyone fine with it? Once again, the values are 3, 5, 8, 17. The triangles are known to us. 3, 5. This will be 4. Another triangle, 8, 17. This will be 15. Okay. I have added sign on my own in the LHS. So on the RHS also, you will have to take sign. Take sign on LHS, take sign on RHS. I'm just simplifying the RHS. Sin inverse goes 77 by 85. So RHS is 77 by 85. Let's try to bring LHS also equal to 77 by 85. Sine of A plus B is sin A cos B plus cos A into sin B. Check, check. Sin A cos B cos A sin B. Looks good to me. Sin inverse 3 by 5. Cos sin inverse cannot cancel. Make this sign as cos. And how to do that? From second triangle. 8 by 17 is in second triangle. So in second triangle, if I want to convert this sign into cos, adjacent hypotenuse, 15 by 17 it will be. Cos sine, wait, I want to put that sign as cos. So in the first triangle, cos is 4 by 5. Sin 8 by 17. Once again, 3 by 5, cos cancel, 15 by 17, cos cancel, 4 by 5, 8 by 17. Can we see the answer? 17 5s are 85, okay. 15 3s are 45, 4 8s are 32, 77 by 85. LHS very much equal to RHS and hence proved. Are you able to understand this type of question very well? You can pause, take a pause, understand it. Next question, guys, very similar, just for the purpose of practice. Sin inverse of 4 by 5 plus sin inverse of 5 by 13 plus sin inverse of 16 by 65 is equal to pi by 2. You have to prove. Okay. So 4, 5 is a Pythagorean triplet. 5 and 13 is again a Pythagorean triplet. 16, 65 is also a Pythagorean triplet. All right. So if you consider the first two terms initially from the LHS, consider the first two terms. Third term we will consider later. So from first two terms, what say? What is sin inverse of 4 by 5? Let's take sine. Let's take sine to simplify. So sin A plus B. Sine of A plus B is sin A cos B. Can I write it directly? Just understand. Sin A. Sin cancel. Cos. Sin A cos B. Now cos of B. Outside there is cos, inside there is 5 by 13. I will draw the triangle. Let's say this is your triangle A with opposite 4, hypotenuse 5, this will be 3. And for B, sine opposite is 5, hypotenuse is 13, this will be 12. Now just understand once again, this is your A, this is your B. First term A, second term B. Formula of expansion is sin A cos B. Sin A, sin inverse cancel direct. Cos B. So cos and sin inverse. So in the second triangle, I don't want sin inverse, I want cos inverse. It will be 12 by 30 plus cos A. In the first triangle, A is sin inverse. So what will be cos inverse? 3 by 5 into sin B. Sin B 5 by 30. First two terms I have taken, 13 5s are 12 fours are and 3 fives are. How much is that? 63 by 65. Alright, first two terms. Next term. Therefore, go easy in the LHS. Sine of first two term we have got. This is sine inverse of 16 by 65. From the first two term we don't want sine. Sine was added by us. So if you remove sine, it will be sine inverse of 63 by 65. It's very simple to understand. Just think people. If you put sine, you get sine theta. If you remove sine from theta, there is a theta. If you put sine, it will become sine theta. If you remove, it will become sine inverse theta. Removing means inverse, putting means right. I can also do one good thing here. You know what? Can I write this sine inverse of 16 by 65 from another triangle, which is C. 16 is opposite, 65 is hypotenuse, so this side should be 63 according to Pythagorean triplet. This sine inverse of 16 by 65, can I write it like this? Sine inverse of 63 by 65, and from this triangle I can write it as cos inverse of 63 by 65. Just check. That's your LHS by including the third term. And sine inverse theta plus cos inverse theta is nothing but pi by 2. That's your RHS. Hence proved. Reason: sine inverse theta plus cos inverse theta is equal to 90. These two should be same. Theta, theta. Same. Answer is 90. Yeah, it was not same. Cos inverse, this thing converted into cos inverse from the third triangle. Sine inverse, we didn't want sine inverse. How to convert to cos inverse? From the triangle. So triangle is always used for the purpose of conversion, nothing else. Remember very well, triangle for conversion. Triangle for conversion, that's it. Next. Cot inverse 13 plus cot inverse 21 plus cot inverse minus 8 is equal to pi. Try to prove that. Let's do. For LHS, cot inverse 13 plus cot inverse 21 plus cot inverse minus 8. Can I write it as pi minus cot inverse 8 using fam 2? Using your property 3, cot inverse of minus theta is pi minus cot inverse theta, right? Now this can also be written as tan inverse of 1 by 13 plus tan inverse of 1 by 21. Why am I doing that? Because we have a formula for tan. We don't have a formula for cot. Do we have a formula for cot? No. Tan inverse x plus tan inverse y, the tan exclusive property, property 5, tan exclusive. What is tan inverse of x plus tan inverse of y? Tan inverse of x plus y upon 1 minus x into y plus pi minus cot inverse of 8. Simplify. Tan inverse 21 plus 13, 34 by 13 into 21 divided by 13 into 21. How much is 21 into 13? 13 2s are 260 plus 13, 273 minus 1, 272 upon 13 into 21. Denominator cancel. Here there is pi minus cot inverse 8. Right now I don't know what to do with this cot inverse, but we'll deal with it. We will left tan inverse of 34 upon 272 plus pi minus cot inverse of 8. I think it's time we write cot inverse 8 as 1 by tan inverse of 1 by 8. Okay. 34 1s are 34 8s are tan inverse of 1 by 8 plus pi minus tan inverse of 1 by 8. The reciprocal property. The very first property, reciprocal property, tan inverse 1 by 8, and here it was cot inverse x. Cot inverse x can be written as tan inverse 1 by x. Tadang tadang, tadang tadang, tadang tadang, tan tanatan. How many properties used, guys? In the very first step, we use your property 3. What was property 3? Cot inverse of minus theta is pi minus cot inverse of theta. Then in second step we use the property cot inverse of x is tan inverse of 1 by x. All of these are properties noted by you. Then in the third step we use the property tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. Right? Third step. Fourth step, simplification. Fifth step, simplification. Sixth step, again we used property 3, that is, this reciprocal property we used, property 1, and we got the answer. And able to understand people, very important questions. And this one especially is very, very important. I would want you all to think about it first before you go for the solution. Just think very well. Try different methods. You will get stuck. Maybe you will get the answer in one step. I don't know. But think. We are going to explore few more properties in this question. Yeah. We have used property 1, 2, 3, 4. 5 also we used. 6 properties left, right? Time to use that. LHS. LHS is 2 times tan inverse of minus 3. And you might encounter question like, ma'am, why are you doing that? How will we come to know whether to do this or not? Answer is simply practice. Try 10 methods. One of them will be correct, and that's what I am doing. I have tried 10 methods and I am writing down the right one. You also have to try 10 and then figure out all the other 9 is not working, 1 is working, that's why. So for example, tan inverse of minus theta is minus tan inverse theta. You know this? First step. Second step, I am converting this tan inverse as cot inverse. Cot inverse. Why am I doing that? Practice. What is the property formula used? Tan inverse of x is same as cot inverse of 1 by x. Next step, I am writing this cot inverse as pi by 2 minus tan inverse of 1 by 3. What is this property? The complementary property. I think this was also not used, or was used by, yeah, we just used in the previous question. What is tan inverse of x plus cot inverse of x? It's 90. Tan inverse of x plus cot inverse of x is 90. From here, what will be cot inverse of x? What will be tan inverse of x? 90 minus cot inverse, and cot inverse will be 90 minus tan inverse. That's what I've written. This cot inverse as 90 minus tan inverse. Cot inverse as 90 minus tan inverse. Multiplying minus 2 inside, we'll get minus pi, minus of minus plus 2 times tan inverse 1 by 3. Right. So far, correct? No problem. Now recall one more formula from tan exclusive. What is 2 times tan inverse of x? It was tan inverse of 2x upon 1 minus x squared. Do you remember? I also corrected the sign in my formula. 2 times tan inverse of x is tan inverse of 2x upon 1 minus x squared. We are going to use that now. Minus pi plus tan inverse of 2 into 1 by 3 upon 1 minus 1 by 9, 1 by 3 the whole square. Minus pi plus tan inverse 2 by 3 upon 9 minus 1, 8 by 9, 3 1s are 3 3s are 3 goes up as minus pi plus tan inverse of 6 by 8, which is equal to minus pi plus tan inverse of 6 by 8 is 3 by 4. We need 4 by 3, not 3 by 4. We need 4 by 3, not, okay, minus sign will take care. So how do I convert this 3 by 4 into 4 by 3? We don't want cot. You will say, ma'am, write it as cot inverse 4 by 3. But do we want cot? No. We want tan only. We want tan and then 4 by 3, not 3 by 4. Oh, now what to do? Now what to do? Whenever such a scenario arises in front of you, you will write it like this. This is cot is not needed, I also know, but I can always write this cot as pi by 2 minus 10. This can be written as pi by 2 minus tan. Can you see the magic happening? Tan inverse 3 by 4, I have somehow managed to get tan inverse 4 by 3. How? Making tan cot, so the angle changes, reverses, and now cot can be easily converted into tan as 90 minus theta. Open up, minus 180 plus 90 is minus 90, and then this is minus tan inverse 4 by 3. Is it matching the RHS? Not yet. We have plus here, minus here. Okay, take this minus inside, big deal. Minus 90, take this minus inside, we will have tan inverse of minus 4 by 3. That's the RHS, hence proved. IMP. Try to understand each and every step. I have given the reasoning also as far as possible. Here the step was tan inverse of x written as cot inverse of 1 by x. Try to solve this question once again, guys. You are going to enjoy it. And cot inverse of x is equal to 90 minus tan inverse of x. You are going to love this. You are going to love this question if you solve on your own and get the answer. Try it, people. Try it. Try it. Alright, so I'll be taking one last question now and then probably ending the chapter for now. More practice sessions, more questions can be taken. Let the time come. Next, to conclude from where we started. Find x if sin inverse x plus sin inverse 2x is pi by 3. Let's find the value of x. The first step, I have kept sin inverse 2x on left side and sin inverse x transferred on right. We need x, people, remember. So from left side goes on the right side, sin of pi by 3 minus sin inverse x. Enjoying these questions, and this very interesting. Now sin of a minus b is sin a cos b minus cos a sin b. Sin pi by 3 is root 3 by 2. Cos of sin inverse x, once again triangle. Whenever things don't match, we have only one rescue, our triangle. There's cos and sin clash. So okay, sine says x upon 1, opposite is x, hypotenuse is 1. So what will be adjacent? Root of 1 minus x square. We know it's also a Pythagorean triplet. Alright, so cos, the sin inverse x from this triangle, if I want to write it in terms of cos, it will be adjacent upon hypotenuse. Let me write it directly, 1 minus x square upon 1. No need of writing upon 1. Cos pi by 3 is 1 by 2. Sin inverse cancel, x. This is equal to 2x. Minus x by 2 on the left side, 2x plus x by 2 is equal to root 3 by 2 times root 1 minus x square. Simplify to get the x. Now normal algebra, guys. 2x plus x by 2, 2 and a half, 5x by 2 is equal to root 3 by 2 times root of 1 minus x square. 2 cancels. Now square on the both sides. 25x square is equal to root 3 square 3 into 1 minus x square. Open up. 3 minus 3x square. 25 plus 3x square, 28x square is equal to 3. X square is equal to 3 by 28. X is equal to plus or minus root 3. But out of both the values, which value are we going to take and which value should we reject? One accepted, the other rejected. One positive, other negative. Just think. And with reason. You should also know the reason. If I take a negative value, sine inverse of minus theta, sine inverse of minus theta, we know minus sign comes out. So overall answer will be negative. So minus sign will give me a minus answer. Do I want a minus answer? No. Positive answer. So these values have to be positive, isn't it? Makes sense? We will reject this. Negative is rejected. The only answer of x is root of 3 by 28. I hope you can understand the simple reason behind why that's rejected. 2-minute summary. What is there in the summary? In the ITF chapter, we studied some basic properties, then 6 important properties which are very important. Most of the questions are based on that. In the end, we practiced lots of questions. But first and foremost, before all this, there was a table which we had to by heart. The table, its domain range was by hearted. So from today's class, all you have to take is how to remember the table. I gave you the logic also, third quadrant nothing, theta cosec, cosec cot. 2 basic properties, 6 important properties and questions on them. All the properties we used in the questions. That's it from my side for this chapter. If you have enjoyed the session, do share it with your friends and also let me know. Thank you so much. See you all in the next class. Bye-bye. Thank you.